In our discussion of galaxies, we talked about big galaxies and small galaxies. Well, the bigger the galaxy, the more gravity it has. And so a really big galaxy could have enough gravity to hold a small galaxy in orbit around it. And so in that case, the smaller galaxy would be a satellite galaxy of the bigger galaxy. So in this image right here, we've got the Andromeda Galaxy. Andromeda Galaxy is M31, and it's got these two little small satellite galaxies, M32, which is a small elliptical galaxy. It's close to an E0, and then another elliptical galaxy is M110, also known as NGC 205. And these two galaxies orbit around the larger M31 Andromeda Galaxy. Our own Milky Way galaxy has satellite galaxies as well. And so the two largest of the satellite galaxies are the Magellanic Clouds, named after Magellan, though he was obviously not the first person to ever see them, but he was one of the more famous people to report back to Europe about them. They cannot be seen from the northern hemisphere because they are very far in the southern sky. And so you have to be pretty far south to see them. And so when he sailed around the world, he got views of them. There are actually two of them, two little clumps. They look like little bright patches in the sky, little fuzzy patches. The larger one we call the Large Magellanic Cloud, and the smaller one we call the Small Magellanic Cloud. The Magellanic Clouds and M32 and NGC 205 are not the only satellite galaxies. Turns out there's a clump of galaxies that orbit, so small galaxies that orbit around the Milky Way. So we got the Milky Way and a clump of galaxies orbiting around it. M31, the Andromeda Galaxy, has a clump of galaxies orbiting around it. Even a fairly decent sized companion galaxy orbits sort of with the M31. They orbit each other, and they have a handful of small galaxies there. These two clumps are moving around each other as well, and so the entire group is a group of galaxies here with a couple other little smaller galaxies mixed in, is a whole group of galaxies here that the Milky Way belongs to. Galaxies, like stars, often don't form by themselves. They form in clusters. And so this little group of galaxies we call the local group. So the local group, kind of a plot of it in 3 dimensions here, showing the different galaxies that make it up. Most of these plots are kind of, centric on the Milky Way because we generally consider ourselves important. And so we got the Milky Way and its companions here. We got the Andromeda Galaxy and its companions up here, and then a few of these others that are scattered around. And they're all moving around each other, all gravitationally interconnected. And so this is the local group. That's the nearest galaxies to us. If you were to make a map of the sky, so across the zero of this map in the middle, the equator of the map is actually lined up with the Milky Way. And if you were to plot all the different galaxies that are in the sky, one thing you notice is they tend to avoid a region of space real close to the Milky Way. So on these maps of the sky that show galaxies, you don't find very many galaxies there, and we call that the zone of avoidance. So why are the galaxies avoiding that spot? Well, they're not avoiding that spot. They're not avoiding that spot at all. There's plenty of galaxies there. We just can't see them. Why can't we see them? Well, I just said that lines up with the Milky Way. So the plane of our galaxy, so that means that the dust and gas that makes up our galaxy kind of gets in the way right there.